Let's do one more example before we move on to the chord of contact using the Cartesian tangent equations. In fact, not using that one anyway. So this is a Cambridge example, pretty similar to what we got before about y-intercept, except this one is the x-intercept. So first of all, we need to write down the general form of a line that with the x-intercept of 2. So in this case, we only know that when x equals to 2, y equals 0, and we don't really know what the gradient is. So in fact, we will write it in the form y equals to m times x minus 2. The reason we do this is to make sure this line equation, when x equals to 2, y equals 0. So therefore, that is my line. And then we're going to solve the line and the parabola simultaneously. In that case, the parabola is x squared equals negative 6y, and y equals to this, m x minus 2. So x squared equals to negative 6mx plus 12m. Tidy it up a little bit. X squared minus 6mx, plus minus 12m equals 0. Now, discriminant equals to 6m all squared minus 4ac. Don't forget, it's the 12m is the whole thing, not just the 12. 36m squared plus 48m. So in this case, since the line is a tangent, discriminant equals 0. Therefore, 36m squared plus 48m equals 0. Now we're taking, what is that? We take 12m out. That's 3m plus 4 equals 0. M equals 0, or m equals to negative 4 on 3. Okay, so therefore, the equation of the tangent are y equals to, when m equals 0, which is 0, or y equals to negative 4 on 3, x minus 2. Why y equals 0 is also considered as a tangent has x-intercept of 2, obviously, because that's the x-axis that passes through 0, 2. Sorry, 2, 0, which is the x-intercept of 2. Okay, now, the next part of the lesson, we will try to introduce the idea about the chord of contact of the parabola. Contact of a parabola. So now, let me introduce what that is first. That is, if we have a parabola, x squared equals 4ay, from an external point T, there are two tangents can be drawn. Oops. Two tangents can be drawn. And it will basically touch the parabola at P and Q, 2 points. And what we call the chord of contact is basically the chord joining the points of contact. So this is what we're looking for. That is the chord of contact. So our target is basically to find out the equation of this chord. And remember, the chord of contact has only Cartesian form. There's no parametric form. In order to derive the equation of chord of contact, this is actually quite a complicated process. You have to understand this. So you might actually want to watch this several times. First of all, we derive the chord of contact from these 2 points. So if I call point P is x1, y1, point Q is x2, y2, and T is x0, y0. Now, our target is by given a value of t, which is x0, y0, can we actually just get the code of contact straight away? So basically, that's what we're trying to get, and that's what's given, x0, y0. Now, in order to derive this, we need the true prior knowledge of the tangent equation. So we start with tangent at P, which is x1 equals to 2a brackets y plus y1. My bad. So this function is still x squared equals 4ay. I should have stated at the beginning. And tangent at Q, that is x2 to a y plus y2. This is really simple. We just substitute it in. And here is the essential part. Now, since point T lies on both tangent, of course, because T is the intersection of the tangent at P and tangent at Q. So therefore, we are going to substitute the x and y coordinates of point T into both tangents to get the two equations we need for future use. That's called equation 1. By substituting x0, y0 into the tangent at P. And we're going to substitute x0 and y0 into tangent at Q as well. So basically, this is a fact. These two are no longer equation. I mean, it's no longer variable equations. They are just fixed relationship now with x0, x1, y0, y1, and x0, x2, y0, y2. All right, now here is something that you always need to memorize. This is out of nowhere. Now, we construct a line L. And we know the answer, what we need, so therefore we make up the answer and now try to prove this answer is actually working. So we construct a line L with equation x0 equals to 2a y plus y0. Now this looks extremely similar to the tangent equation of both of these. But in fact it's not, because it's not x1, y1, we're using x0 and y0. And now, how do we actually use this? Now, if we construct this point, that means now if we sub point P, sub the x and y coordinates of point P into this equation L we just made up, that will give us x1, x0 equals to 2a brackets y1 plus y0. Okay, and from what is this? This is basically my equation 1 that I have proven that it's always true. Therefore, from equation 1, I know point P lies on the equation L. Now, if I do the same thing again, if I sub the x and y coordinates of Q into my equation L, that will give us x2, x0, substitute x2, y2 into this, and now you see this is in fact my equation 2, which we have already proven that is true again. So therefore, from equation 2, point Q also lies on the equation L. Oh, sorry, shouldn't say equation, just write lies on L. L is the equation. So therefore, L is the one and only one line that passes through P and Q. Therefore, L, which is x0 equals to 2a y plus y0, is the chord of contact, because that is the one and only one line that we want to pass through P and Q at the same time. So therefore, that's it. Now, I need to make this very, very clear for you. This is the chord of contact. It looks extremely similar to the tangent. So I'll rewrite this. Tangent, we will have x1 equals to a y plus y1. And chord of contact, we have x0 equals to a y plus y0. So what's the difference? The difference is x1, y1 is a point on the parabola. So in other words, if you're using this formula with a point on the parabola, substitute a point on the parabola into this equation, it will give you a tangent. However, if you substitute a point that is external of the parabola, point of the parabola. If you substitute an external point into this equation, that will actually give you the equation of the chord of contact. So that is basically the primary difference, or how you distinguish between these two equations. Okay, so for example, now let's finish this example. So let's given x squared equals to 8y. Well, a equals to 2, by the way. Let's find the chord of contact from point T, which is 4 and -6. This is an external point, and hence very commonly asked. Hence, find the points of contact of the tangents from T for -6. Okay, let me draw the situation first. So you need to know what's happening. So that is a parabola. So we got again 2 points. That's point T for -6. So those are the 2 points we're looking. First is we want to find out this chord, and secondly, we need to find out the points. So using the chord of contact formula, what do we get is chord of contact, just substitute it in. x1, which is 4, equals to 2a, 2 times 2, a is 2, by the way, and then y plus y0. Sorry, that is your -6. So simply just sub that in. That's all. So therefore, what do we have? We have 4x equals to 4y minus 24. Therefore, simplify a little bit, y equals to x plus 6. So that this line here is y equals to x plus 6, which is the chord of contact. In order to find out the points of contact, of course, now you're going to solve the chord of contact simultaneously with your parabola again. So y equals to x plus 6 and x squared equals to 8y simultaneously. Now my video is running out of time. Sorry girls, I can't finish this with you in this video. Check out this one though, I have already uploaded. We have the full solution afterward. So we're going to solve them simultaneously, and when you solve the equations together, you'll get the 2x values, substitute it back into the y to get the 2 coordinates of your P and Q. So that's the end. Okay, check out this bundles later on for the full solution. Bye.